This is 6.2, which talks about the sine and cosine functions. Sine and cosine functions will only exist if we have what's called a unit circle to work with. So this is the first thing that we're going to talk about here. So the unit circle, we're going to pretend that this circle that I just drew here in black is a perfect circle. Okay? And that if I were to draw an x-axis and a y-axis going straight through it, that the very center of this, the origin, would also be the center of the circle. So what's interesting about what's called the unit circle is that it always has a radius of 1 unit. No exceptions, so the radius will always be 1. So if I were to look at a couple points here, let's take a look at this green point sitting right here on the x-axis. If the radius of this circle is equal to 1, what's the coordinate of this point? Well, it would very simply be 1, 0. So then what about the point up here next to the y? That would be 0, 1. And we're going to go around the circle like this a couple more times. So this is negative 1, 0. And then the last one would be 0, negative 1. And these values are going to come into play a little bit later. You'll see how. And with this radius, I'm going to go ahead and draw this in here, just some arbitrary radius. I'll go ahead and put it here, the point. We'll label this point as point P. And this point P has some x and y coordinate. I don't know what they are. Just by looking at the unit circle, it's very difficult to tell exactly where that point is. But wherever P is, it has some angle measure to the x-axis, which is also called the terminal side. Now, this amount of measure has a special name and a special notation in mathematics. So anytime you know the angle measure, we say that it is represented by this symbol, which is a Greek letter, which is pronounced theta. So theta will always represent degree measures. All right. Now, how does this all tie in with the sine and cosine functions, you may ask? Well, using sine and cosine will actually allow me to find the x and y coordinates of that blue point P by using two very simple rules. One of the rules says that this represents sine, S-I-N. If I know the angle measure, so I would do sine of theta. Okay, in your calculator, you're going to have to do that. And whatever that is going to give you the y value of any coordinate on that unit circle that you want. And then in order to find the x value, I would do the cosine of that degree measure, which would be equal to the x value. So I could find the coordinates of P anywhere on that unit circle as long as I know the angle measure. So that's really useful information for us. So I want to take a look at a problem with you from your book, which asks, well, this is all great and nice, but let's try to find the coordinates of one of these points. So I'm going to go ahead and erase some of this so I've got some room to work. And I'm going to try to draw the unit circle again real quick. Here's my unit circle, x-axis, y-axis, and point P is somewhere on here. So unit circle. So let's say I want to know the cosine of 90 degrees. Remember that we filled in a few of those points from the previous page. I'm going to put them back on this picture in green, the same color as I used before. And this point was 1, 0, this was 0, 1, this was negative 1, 0, and this was 0, negative 1. Well, in this problem, it's asking what is the cosine of 90 degrees. And what we just learned before is that the cosine of theta should give me the x value of my coordinate. So if I look at this problem, well, where would that 90 degrees lie? Where do I count my degrees from? In this picture, I want you to look over here with me. Your angle measures will always start right here on top of the x-axis and will always move this direction in a counterclockwise direction. So if this right here measures 0 degrees, a 90-degree turn would be a right angle. So up here at the very, very top, this is where 90 degrees is. And I can't fit the degree sign on there. So just know that that's 90 degrees. And this point over here would be another 90 degrees. So this is 180 degrees. And then this point down here would be another 90, which would give me 270. And then, of course, a full rotation of a circle is 360 degrees. So when I look at this problem, it says, what's the cosine of 90 degrees? Well, if I look at this picture, up here is 90 degrees. So what's the x value? And if I look right here, it shows me that the x value is 0. So that's how I do that. So then how would I do the sine of 90 degrees? And the rule, again, for sine is the sine of any degree measure is equal to the y value. So we're still looking at that same coordinate, and the y coordinate of that point is 1, so the sine of 90 degrees is equal to 1. So let's try another one. Let's do the cosine of 180 degrees. So I want you to look at the picture and see if you can determine that in the next couple seconds. If you say that it is -1, you are correct. Because this right here on the left-hand side of my unit circle is my 180 degrees, and -1 is the x value, which is also what represents cosine. So if that's the case, then how would I be able to find the sine of 210 degrees? Well, when I look at this picture, 210 degrees is not on there anywhere. I know it's somewhere in between 180 and 270, so maybe it's, I don't know, right here? 210 degrees? Okay. And I want to know the y value of that point. Well, if it's not one of those nice points, then we're going to have to use our calculators. So when I open up my calculator, I first of all want to make sure that one thing is certain, and that is that I am in what's called degree mode. And I'm going to tell you how to find it. So open up your calculators and try to follow along with me, because you need to know where this is. In order to get to degree mode, you want to access the math button. And the math button lies on the left-hand side of your calculator, third button down. Once you get there, oh, nope, I'm sorry, it's the mode. I am so sorry. Not math, it's mode. And the mode key is right next to the second button to the right. Once you click on that, you're going to see a whole bunch of information. And the first thing that's going to be blinking is normal. So if you look down, you're going to see where you have a choice, the third row down, between radian and degree. And all you need to do is put your cursor over degree and press enter until it's blinking. Once it starts blinking, then your calculator is in degree mode. So I'm going to find my sine button, which is about in the middle left-hand side. And I'm going to type in 210 degrees. You do not have to write in the degree symbol because I already told my calculator this is a degree. And you're going to close the parenthesis, and if you press enter, it should pop out -0.5 as my y value for that degree measure. So let's try this again. but this time with cosine. So let's try the x value of that exact same coordinate. So once again, your calculator is already in degree mode. Once you do it once, you don't have to go back in to keep telling it that you're talking about degrees. So I'm going to press cosine of 210, and it's going to give me a really big long decimal, but we are going to round to 3 decimal places, 866. So that is my x value. So you can find the coordinates of any point on a unit circle that you want using this method. So the next question is, well, what if you have a unit circle that doesn't have a radius of 1? Well, first of all, it's no longer going to be a unit circle, but there is a way of getting around it. So I'm going to go ahead and erase this. I'm going to show you what I mean. So if I have a circle, and we're going to pretend like this is a perfect drawing of a circle, and I'm just going to draw the terminal side this time. This is x, and this is y. Oh, no, I'm not going to write that. I don't want it to be too confusing. And this is just going to have a radius of r. I am not going to tell you how big it is because I don't know. It could be bigger than 1. It could be smaller than 1. I don't know. Okay? And let's say I've got some point P up here again, and I want to know the coordinates of it, some x and some y. Okay? That still means I need some theta measure here. I need to know the degree of that angle in order to know how to get to that point. So this looks very, very similar to the rules that we just learned, which were the cosine of theta is equal to x. But this time, all we need to do, since it seems like it would be getting bigger or getting smaller, is just simply multiply it by however big the radius is. So if your radius isn't 1, then you use this particular equation instead. You just multiply whatever your cosine theta is by the radius that you have. And then so for the y value, we're just going to do r times the sine of theta, which is going to give me my y value. So if I take a look at a quick problem here, let's say I want to know for a circle with, let's just say that the radius is 5, okay? And I say that I want to know the cosine of 135 degrees with this particular circle, then I'm going to follow this formula. So the radius in this case was 5, so I'm going to write 5. And I'm going to multiply that by the cosine of 135 degrees in my calculator, because I don't know that by heart. It's not one of the nice ones. It's not 0, 90, 180, 270, or 360. So I'm going to have to use my calculator. And I'm going to go ahead and type that in, and I'm going to see what I get. We're going to round to 3 decimal places. So negative 3.536 would be my answer for that. So that's how we're going to work with these kinds of problems. And just to verify this answer, let's try to think of where 135 degrees would be on this picture. I know that if this terminal side were to continue this direction, this would be 180 degrees. So 135 should lie somewhere between 90 and 180. So, I don't know, maybe somewhere near the middle. So this does make sense that the x-coordinate, this value right here, would be negative, because this point, if I follow it down to my x-axis, all these values over here are negative. So that's another way you can verify your answer just by looking at your picture.